how many of you took more than the 2 hours average on this assignment? Yeah, I told you it was going to be, okay, I promise not to give you one. Although the number, or the sieve of Eratosthenes wasn't that difficult, it did take quite a bit of time. Does everybody know why they call it a sieve of Eratosthenes? Eratosthenes was the guy that developed it. A sieve, it's just a kitchen instrument, right? You're making spaghetti, so what do? You boil the water and the noodles, right? And then you take your sieve, and you go over the sink, of course, and then you dump all of it into the sieve. What happens? The water goes through the holes in the noodles. The spaghetti stays in the sieve. Most of it, depending on what kind of pasta it is and what kind of sieve it is, I guess. But that's the idea. Okay, so Eratosthenes, this was over 2,000 years ago, invented this way of sieving out the primes. You take all of the counting numbers, and the number 1 and all of the other composites drain through, leaving you with the primes circled in the sieve. And there they are. And you just have to eat them. No, you just have to use them, right? Okay, so we're going to talk about that experience and what we might learn from it, even more than what you might have already learned from it, a little later in the class. First, I'd like to go to the other part of the homework that dealt with the factors and the number of factors and so on. Let's just pull that up here. Pick on. There we go. This is the one you, whoops. How come it's doing that again? Let's try turning it off. Giving it a second or two, turning it on. Still getting the top half taken off. Maybe I didn't pause long enough. Don't you just love technology? Huh.
No, it says the lamp. It's blinking on lamp.
So yeah. So what I'm going to do is I'm going to push shut down, let it shut off. Okay. Raise your hand if you had some difficulty in answering every one of these questions. I kind of fully expected all of you to have some difficulty. All right. Some parts were more difficult than others. And so let's talk about how you went about doing. Oh, no, let's ask this question. What did you do when you had trouble and you couldn't answer? What were your options? What did you do?
I looked it up on the internet.
You went Googling. Okay. What did you Google?
I just Googled like the general rules about factors, and then I went through and read a few of them.
Kind of went from there.
Right, and then after reading it, like reading the rules and then reading the question again, it made more sense what the question was asking.
Okay. What did some of the rest of you do besides go to the internet?
Threw my hands up.
Threw your hands up.
Just on 2 of them, though.
Just on 2. Well, if you just threw them up on 2 and they were the right 2, you're okay. Okay? Yes, what'd you do?
Well, 13 and 14, those were the questions that really stumped me. And so I just looked at the relationships between the numbers and just like the different ways they could impact each other. And I was never able to find the right equation, but it gave me more of an understanding.
Okay.
With numbers.
Okay, so there you had trouble with a couple as well.
Yeah.
Okay. Where did you go?
I went to just like different old textbooks that I've had to look at definitions.
Pulled out some other resources. Anybody else? Yes.
I went to the math lab.
Went to the math lab. Anybody go to the math lab? About 4 or 5 of you? Okay. Did you get some good help?
I did.
Okay.
Asking the right questions is the key.
Asking the right questions, but people were able to help you. Any other ways we could get help if we come to something we can't do in this class?
Pray.
Yeah.
Yeah, I think somebody else just said it too, but I was going to say pray.
Pray. That's always a good one. Okay. Especially at BYU Idaho. Yeah.
Contact someone else in the class or visit me.
Contact someone else in the class or visit me. I did have about 4 visitors on this assignment. Anybody think of anything else? We've got several here, yeah?
Take a break and get your mind cleared off.
Go in and get a snack and come back and let your mind clear and come back and you say, oh, yeah, that's obvious now. Sometimes that's all it takes. Good. Good strategies here. Anybody else have any other ideas? Maybe you know your high school math teacher really well and they don't mind if you call him. No. Maybe he's your uncle. I don't know. Phone a friend that knows, right? Yeah.
Well, my roommate took this class last semester.
Roommates that have had the class maybe could be helpful. Okay. Did you know that you read my syllabus, you can hire at no cost to you a tutor for not just this math class, but any class you have at BYU Idaho and get up to 3 free hours per week. Does everyone know how to do that? Does anyone not know how to do it? I outlined it in the syllabus, but you can either go to the math lab and right next to it is the tutoring center and you can go in and sign up in person or online. I explain how to go to a certain place on byui.edu and sign up for it. Automatically, just do it with the computer and get it all arranged. This will be the last time I give you an assignment that long. It will not be the last time I ask you to do something that I haven't taught you to do. But let's just see here. Where did this 1 and 2 come from?
The exponents.
It's the exponents. It's this 1 and this 2, right? Where does this 6 come from? This is all the factors that we listed, right? And we've shown you, if you have a graphing calculator, how to find them real slick, right? So you just count them and you write how many, right? Then, in the table above, highlight the rows where the number has only one prime factor. This one has only one prime factor of 2. This one has 2 prime factors, 2 and 3, right? So would we highlight the number 18? No. Yes.
I had a little trouble on that with the wording. I didn't know if you meant the exponent, like it just has.
Help me get this a little better so that people will understand it without going
Well, what I went
to
into
some
for
help.
help, the person who helped me, they're like, he wants the base. Just the base of not the exponent, but the prime base.
In the table above, highlight the rows where the number has only one prime factor. Maybe I should have had you go up to this one, because there's 2 prime factors. And there's, I don't know.
Well, when you look at it, like, number 4 is 2 to the 2. So it only has one prime factor, but when you read the question, I was like, well, technically it has 2 2s. So then at first I was like...
Yeah, but it only has one prime factor.
Right, but just the wording is funny at first.
Help write it up if you think it would, if you know how to say it a little better, and send it to me and I'll consider that to make it, because, all right. So what we've got is several of these numbers highlighted, right?
Yeah.
Then what do we do?
What if you put an example on here, like this is what I'm talking about?
Like one example, like you gave us examples on the chart above and below, and that really helps.
So-
But maybe highlight one of them so we can kind of know
Okay.
what to pattern our.
Okay. That might be helpful. Okay. Compare the exponent in the prime power factorization of those numbers that you just highlighted with the number of factors. In other words, compare the exponent with the number of factors. What did you find?
You just add 1.
You just what?
You add 1 to
You
the
just add 1
The number
to the number of
exponents.
in the exponent. Okay, so there was 1, an exponent was 1. I just added 1 to it and got 2. Down here with 9, 9 was what? 3 to the second. So I take the 2, the exponent, and add 1 to it and get 3. Aren't there 3 factors of 9? 1, 3, and 9. Everybody see that? I fully expected everyone to get the answer to question 4. How do you know that I fully expected you to get the answer? No, because when you got to the key, there was no asterisk by it. Who knows what I'm talking about?
Oh, I totally forgot about that.
Okay, let's talk about that a little bit. So, if you get that part for number 4, then getting these other questions right here, state a rule for determining the number of factors for any number that has only one prime factor. Can you state a rule? Can somebody state a rule?
We'll go back and we'll start.
We'll talk about it in just a second. What's the rule? How do you determine the number of factors of any number that has only one prime factor?
You take the number that the exponent is and add 1 to that, and that's the number of factors that it'll have.
We okay? Now, somebody tell me a number they found that has 9 factors.
256.
How do you know that is?
Because if you go 2 to the 8th power, it's 256, and if you follow that
That's
rule,
2 to the 8th.
Yeah.
Is that the only number that has 9 factors?
No.
What else would be?
5 to the 8th.
3 to the 8th, whatever that is, would also have 9 factors, right? 17 to the 8th. Any prime number to the 8th power would fit that, correct? Now check to see if your prediction did have 9 factors. Well, this one's going to be easier to check than 17 to the 8th, right? Okay. Now let's investigate where those factors come from. Write the prime power factorization of the number 81. Using the tree method, we'd probably go 9 and 9, right? Because most of you don't keep in your head that it's 3 times 27, do you? But that would work. And that's 3 to the 4th, right? So that's the prime power factorization. Using your rule from question 5, how many factors does 81 have? 5. List all the factors of the number 81. 1, 3, 9, 27, 81. We said there would be how many? 4 plus 1 is 5. 1, 2, 3, 4, 5, right? Write each factor of 81 as a power of the base of the prime factorization. What's the base? 3. So I want to write each of these as a power of 3. So this is 3 to the 3 to the 3 to the and 3 to the 4th. Okay, I'm going to put you in charge of that, just pointing it where it needs to be. 3 to the 4th. What about this one? 3 to the what? 0. Right? Every number raised to the 0 power is 1. Do you remember that from algebra? 3 to the 0. Okay. So the question I want to ask is, why do we add 1 to this here to find the number of factors? Why can't I just take the exponent and say there's 4
Well, because the number 1 is always a factor.
of every number?
Yes.
So we can't forget it, right?
No. And so 3 to the 0 is the number 1, but it's not included unless we add it.
So if we do this one to get all 9, I'm going to start with 1, right? 2, 4, 8, 16, 32, 64, 128, and 256. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like we said it was going to be, right? Well, I can get all of these. This is 2 to the first, 2 to the second, 2 to the third, etc. But this one comes from 2 to the 0. Why do we have to add 1?
It's a factor.
So we get that factor of 1. In other words, we get the 0 power. Is that making sense? That's why we add 1. If we didn't add 1, we couldn't get the number 1 as a factor of every number. We all right? Well, let's go back over here then. I'm going to skip clear down to number 12. 12 has us go back and look at the ones we didn't highlight. What were they? Ones that had 2 or more primes in their prime factorization. Such as? Somebody have an example of one that was there? 10. What is it? 2 times 5. So it's 2 to the first times 5 to the first, right? And how many factors does 10 have? 4. How am I going to take these two numbers and get a 4? Now this was where legitimately the assignment started to become difficult. I'll agree with you. Tell me some of the blind alleys you went up.
I started just trying to add them.
Add them. So 1 plus 1 is 2. Then what'd you do? Because you got to get 4. Then you said maybe I have to double it.
Yeah.
So then you try that with the other numbers. Can I add the 2 numbers and then double the sum? Did it work for any of the other numbers? Some of them it did. Yeah. But as soon as you find one where it doesn't, you got to say, no, that's not it. What are some other things you tried? I would have hoped that this first experience of adding 1 did something to you. So maybe you took these 2 and added them and then added 1 to that. That'd give you 3. How are we going to get 4 from that? That's not going to work. Do you see how I'm thinking about it, though? Or
then after that, I added 1 to each one and then added them again, trying to figure them out.
You added 1 to each one. 1 plus 1 is 1. 1 plus 1 is 2. 1 plus 1 is 2. 2 plus 2 gives me 4.
But it doesn't work for all.
But that doesn't work. Which one didn't it work for? 9. 9 we had... Oh, no, 9's got only 1. Give me one that's got 2 prime factors. 100. 100 is 2 to the second times 5 to the second. If I added 1 to each of these, that would make this 3 and this 3, and then added those would be 6. But 100 has how many? 9, not 6. So that didn't work for that. Does everybody see how you test things and then abandon them when you find out that it doesn't work? How many of you came up with and actually discovered this rule? With help from the math lab? No. No. And why would I put this on there? To make you think. That's my job. But did I hold you accountable for it on the key? When you got to number 12, what did you see? An asterisk. What does that mean? Well, if you read the rubric at the beginning, it says there are two rubrics. One without asterisks and one with. The without, you've got to get exactly what I put or you don't get the full points. On the asterisks, what do you need to do to get the full points?
Try.
Give it your very best shot. Now, you're the one that knows what that is. So if you didn't see the asterisk on 12 and you want to go back in and make your score more honest, go back and do that. Okay? So what did we, those of you who did find it, what did you find? We're almost there.
You add 1 to each of them and then multiply them together.
Add 1 to each. 1 plus 1. 1 plus 1. Then multiply and get 2 times 2 is 4. Add 1 to each of this. 2 plus 1. 2 plus 1. Multiply and get 9. Does it work every time? Does it work for the problem we worked on Wednesday? Who remembers the number? 25. 20, this was it, right? And what was the prime factorization of it? Right? Let's apply the rule that we just came up with. Do what?
4.
3 plus 1. 2 plus 1. And where'd you get the 1? It's implied. It's not written, it's implied. So 1 plus 1 and 1 plus 1. And that's 4 times 3 times 2 times 2, which is
48.
48, which is what I told you it had, right? How did I know without even knowing what the number was? I knew the trick. Now,
So just to clarify, you take the exponent and add 1 to every exponent?
to every single exponent. Why?
And then multiply it?
Because I want to get the amount of factors for just
One
one.
is a-
I've got to get that 0 exponent for each one of those
For
factors.
each one specifically. But if there's more, then you add 1 to each one individually and then you multiply them.
Yep. Why do we multiply them?
Because you're still at that place.
You can just add them.
Okay, let's see if I can make a connection here. Everybody agrees we add 1 to get the 0th. So basically what I'm saying right here is I'm going to take 2 to the 0, 2 to the first, 2 to the second, and 2 to the third. Right? This one is 3 to the 0, 3 to the first, 3 to the second. That's all the powers here if I get the 0. And this will just be 5 to the 0 and 5 to the first. Here will be 7 to the 0 and 7 to the first. Okay, now see if this is familiar. I've got 4 pairs of pants, 3 shirts, 2 shoes, and 2 belts. And I want to know how many different outfits I can wear. Well, I can put this pair of pants with this shirt, with this pair of shoes, with this belt, and I'll get 1 times 1 times 1 times 1, which is the factor 1. I'll get 1 times 1 times 1 times 7. Now I'm taking a different path through my counting tree. And what did I get? 1 times 1 times 1 times 7. Guess what? 7 is a factor of this number. I'm getting all 48 of the factors by taking all 48 paths through here. Now I've done these 3 with both of those, so now I've got to do something different, right? So now I'm going to go here, here, there, and there, right? What's that? It's 1, 1, 5, and 1. So 5 is a factor of this number. 1, 1, 5, and 7. There's another path, so another number that is a factor is 35. I think we had that in one of our pairs up there, right? Do you see how I'm going through and taking all possible paths or all arrangements of outfits? That's why we multiply them.
So continue, what's the next step? You go down to 3?
So I've gone these two. Let's see, I did all across, then all across here. So here, there, here, there. So now I'm going to go here, 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 here. Then here, 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 like this. If you do it in an orderly way, you won't miss any of them. You'll have all 48.
It'll be a while, right?
But that's how I could get them all. That's another way I could get them all. Question. This is what you need to be able to answer on an exam that I give you. I may give you one that has the prime factorization of something like this. 3 to the 4th times 5 to the 2nd, and say, how many factors does that have?
5 times 3, 15.
15. Guess what? Then it's a perfect square. Isn't it? It's got an odd number. It's got to be a perfect square. Do you know what the perfect square is? It's 45 squared. How did I get that? I broke this in half. 3 times 3 and got 9. Broke this in half, got 5, went 9 times 5 and said 45 times 45 will be this number. Do you follow that?
You didn't break the 5 and a half though. You took that one and made it
Half of this
to the squared. So
is
that's
3 squared.
Squared. And
That's
then so
9.
They have the same
Half of-
powers.
Yeah,
But you didn't cut the 5 in half. You just left it as 5.
You took 5.
took 5 squared,
Half
and
of 5 squared is
half of it is 5 to the 1st. Half of,
Oh. Okay,
See?
I hear what you're saying.
so this is really 3 squared times 3 squared. Remember your algebra rules, when you're multiplying you add the exponents, right? And this is really 5 times 5 because you add the exponents. So now if I circle these together, right, and circle these together, they're both 9 times 5, which is 45, so it's 40. This number is 45 squared. It is a perfect square. I don't know what 45 squared is, but it is a perfect square.
So when you were doing the lines over there, you got 175 and 35. How did you get those numbers?
Taking different paths through my tree,
So you did
my
like,
counting tree.
You did straight across, which was 2, 3, 5, and 7. And how'd you come up with
That was 1. 1 times 1 times 1 times 1. To get my 7, I went 1 times 1 times 1 times 7.
Why did you do 7? 1 times 7?
Well, I already done the 1 times 1 times 1 times 1, so it doesn't do any good to go that same tree again. I got to go a different route. Does that make sense? Okay. So you need to be able to find out how, by the way, you said there's how many? 15, because plus 1, then you multiply, right? 15. And then I might ask a question like this. Why did you add 1? Can you answer that? What would you say? Because I've got to get the 0 power because 1 is a factor of every number, and that's the only way to get it. That's why we add 1. Then why do we multiply? Why did we multiply on the outfits? To get all those possibilities. Okay, does that make sense? All right. If you know where the formula comes from, why we're adding 1 and why we're multiplying, you won't need to memorize anything. You'll just need to think about it and you can come back to it. Okay. I want to spend the rest of our time having you get in some groups, pairs, threesomes, whatever's handy wherever you're sitting, and let's have you answer these questions that have to do with the sieve of Eratosthenes. You'll probably want to pull your sieve out. If you did it on a piece of paper with actual colored pencils, if you did it on technology, you'll want to pull your laptop up and actually look at it, because you're going to be needing to take a look at the sieve that you produced to be able to answer these questions. Thank you for asking. The question is why do we multiply? Why is this multiplication here? Why is this multiplication here? If I go to Subway and I get to choose 3 breads, what breads might they put the sandwiches on? Wheat. Choose something that has a different letter. Sourdough, Italian. Okay, there's 3 breads. They have more than that, but we'll just use 3. Let's say you have 2 meats. Somebody give me a meat. Turkey. Ham.
Chicken.
Okay? And if I'm going to make a sandwich and all it's got is bread and meat, how many different sandwiches can I make? 6. We can actually list them out here, right? Wheat with turkey. Wheat with ham. Then sourdough with turkey. Sourdough with ham. Then Italian with turkey. Italian with ham. Right? Now, what if I say they've got 2 cheeses you could use? Let's come up with some cheeses. Provolone.
Swiss.
And Swiss. Let's not use Swiss because we got an cheddar. Okay. Now how many sandwiches can I make? 12. Well, can you see that it's these 6 here, each with provolone, and then these 6 here, each with? Can you see why it's multiplication? Because each time I have, if I would have had 3 cheeses, we would have had to make 3 sets of these sandwiches, right? Do you follow it?
Yeah.
This is actually called the multiplication principle of counting, which says if I have A things of one kind and B things of another kind and C things of another, and we could keep going, and we're going to choose one of each, you can find the total number possible by multiplying how many of each kind. That's if you choose one of each kind. How many of you know about Baskin-Robbins?
30.
They call it 31 flavors, right? I don't know if they have 31 flavors, but we'll assume that there's no false advertising. If I go there and all they have is a regular cone and a waffle cone, and I get 1 scoop, how many different ice cream cones can I get? 62, right? Because I can get 31 flavors of the waffle and 31 flavors of the regular cone. Do you follow that? Is that helpful? The multiplication principle of counting is really what it is. It has a name. And it works because of this tree. See, here's my W, S, and I branch. Then what? T, H branch coming off of each of those. And then coming off of those I have a P and a C branch. And how many total paths through this tree are there? You just multiply, right? That's another way of looking at it. Okay. There's your questions. Talk about them with your partners, with your and this is online. If you look for it.